We'll admit Shayna into the classroom and we will get started on this next topic. So what we have been talking about so far in the class is we've been talking about, some basic biology. And I hope that at this moment, what you realize is that a lot of what motivates our behavior and what we do has to do with that drive, motivational, emotion filling system. Okay. And yesterday we shortly touched on how things like memories, such as defining what emotions and feelings are, determine how we feel and whatnot. Now we're going to add an additional layer to this, though, is we're going to get more in depth about one, our memory system, and two, our learning. But just like when we talked about feelings and emotions and stuff like that, for an academic conversation, we need to separate things like learning and memory to kind of give them a definition that we can kind of work with in order to understand them from at least a measurable perspective or a research perspective, but also to differentiate between two systems. And that's our memory knowledge system and how we actually make behavior change, because they are two separate things, as we will see. So first, we need to define what is learning versus what is memory. Okay. So if you look at this chart, this on the top of this slide, you can kind of ignore the bottom part for right now. When we talk about learning, what we're talking about is a change in behavior, whether we do something less or we do something more. Okay. When we talk about memory, however, what we're talking about is knowledge and our recollection of experiences. Okay. Now, a lot of people will say, well, we use our knowledge and our recollection of behavior of past experiences to determine current behaviors. That is true to some extent. Okay. Because I really want to just spend a moment and kind of give us an understand why we need to differentiate the difference between learning and memory. Okay. And kind of two salient examples that come to my mind are the first one is addiction. Okay. A person with an addiction, which, if you remember from the consciousness perspective, addiction, when it comes to substance abuse addiction, that substance is heavily influencing one of our reward and pleasure centers within our brain. And it doesn't instantaneously. And our brain is amoral. So it will seek out that sensation over and over and over. Okay. And so when we look at addiction and we go, well, if someone has gone through rehab, if they've gone through drug and alcohol classes, if they've done this, they should have the knowledge to change their behavior. But indeed, what we find is yes, people can go in and out of rehab, go through all kinds of addiction classes and get knowledge about addiction and their substance use and all of that. And that may not change their behavior at all. That may not change their addictive behavior. Usually what we find is that there has to be what's commonly known as the rock bottom experience, where someone kind of loses everything or loses something very important in their life, is on the verge of a sickness that leads to death, all of those kinds of things, loss of job, all of those things, in order for their knowledge then to start influencing their behavior. Okay. Or at least them allowing them to use their knowledge about how they should change their behavior. Okay. So And a couple more examples include, for example, in my personal life, one of the very first topics I became very interested in the field of psychology is intimacy and intimate love. Okay. This started way back in 99. And really, the reason why I got really interested in this is because one of my first careers coming out of psychology and my undergraduate degree was in the field of domestic violence and sexual abuse. And so I became very interested in knowing what makes some relationships go horrible and some relationships last decades in a loving, caring way. And I've spent since then doing research and following research within that field of study. However, despite, well, what is that, 26 years of studying this topic in very detailed ways and following all the new research that comes out, that doesn't mean I don't make the same mistakes in my intimate relationships. I still say stupid things. I still get frustrated. I still get jealous. I still, all of those things that humans experience that kind of can make relationships rocky or make relationships difficult, um, still make the same mistakes. And anyone that studies this field will tell you the same thing. Um, and so the problem with knowledge, however, the only thing that it has done for me is you have that you knew better moment after you do something stupid, but that doesn't mean you still don't do things stupid. Okay, so again, knowledge does not always equate into behavior. um, just to drive this home, uh, uh, um, we can think of, we didn't touch much on this in the developmental section where it studied really in detail, but the idea of morality and moral action versus moral knowledge. Okay. Um, People who score very high in moral fortitude, if the situation is just correct, they then can behave immorally. Okay, and we'll give some examples in the social psychology section when we talk about the Good Samaritan, and how even someone who has dedicated their life to morality and faith and religion and moral, being a moral, good, helping person, if the situation is correct, can act not in such a helpful, moral way. Okay. And if you want to think about the stereotype of Catholic priests as an example in child molestation, that's another kind of example of how even people who have dedicated their life to helping in morality can engage in behaviors that are counter to their knowledge. Okay. Um, and then probably the last and probably maybe disappointing example of the difference between knowledge and behavior is college. Okay. While college may change your perspective on life, it may change the way you view people or the way you view technology, or it may change the way you think about things. If you're a business person, the way you think about business and all of those kinds of things, the knowledge you get in college doesn't actually necessarily equate into behavior change. Okay. And this is something that I really encourage, especially my first generational students in the class, to really think about, because one of the kind of things about college is we go into it hoping that it's going to change our life, but the acquisition of knowledge doesn't always equate into change in behavior and the way we go about acting and behaving in the world. Okay. There's some further steps we have to take in order, for example, the knowledge you have in college to change your life after college. There's other steps we have to take. For example, if you know someone or if you yourself are suffering from addiction, there's other things other than having the knowledge that it's bad for you that changes your behavior. When we come into a moral dilemma, we should understand what the situational variables are because there's other things that are going to determine how you behave in that situation other than how you feel yourself as a moral individual. And that's kind of the goal behind this next added layer of information that we're going to go through in this class is understanding how these systems work. We're going to look at them separately. And then at the end, we're going to try and combine what we learned about defining the drives, motivation, emotions, and feelings, and what we learned about learning and behavior change and memory to really come up with some models about how, if you really want to change your life, just reading a book or just avoiding things are not always going to lead to actual behavior change. Okay, so that's kind of our goal. So I first want to start with a conversation about behavior. Okay, and in the field of psychology, if you remember, if we go back to week one, the study of behavior. So when we say study of behavior, we're talking about stimulus response association, where a stimulus is introduced to someone in the environment, and we note whether their behavior increases or decreases, or is consistent or inconsistent. Okay. So when we talk about behavior, we're looking at actual behavior of an individual. Okay. And as I noted, behaviorism started in around the 1930s, but there were some predecessors to behaviorism, which we'll get to, which gives us kind of the methodology that behaviorists are going to use. And then we'll talk about some behaviors. Pavlov really wasn't a behaviorist, but we'll get into him because he's kind of the another model that we're going to use. And then Watson, B.F. Skinner, and Bandura are really going to be the individuals that we're going to talk about behavior and behavior change. Okay. And then we're going to come to the end of behaviorism with a gentleman named Edward Tolman, who's going to show that, maybe memories and knowledge are kind of important to guiding our behavior more than we think. And internal workings of the individual are more important than what we give them credit for. Okay. So let's start with, though, a few of these individuals. So again, I just want to bring this about what we're talking about in this first section when we talk about behavior and behavior change, or response to the environment, is that we have a stimuli in the environment. So we present a piece of candy to somebody, and we look for a response. Does the person take the candy or not take the candy? That's a simple example. Okay. What we're going to ignore for a little while with the behaviorist movement is anything that happens between the stimulus and the response. Anything that happens inside the brain, inside the body, the emotions, the feelings, or whatever, are going to become irrelevant for a little while. But as you will see, from the conversation that we just had, we will be reintroducing those mental processes as we move along in these lectures. But for now, what we're focusing on are stimuli in the environment and the response of the individual or the organism. Because as you'll see, most behaviorists really didn't use human beings, they used animals. And through anthropomorphic arguments, they argued what we observe with animal behavior equates to human behavior. But again, as I mentioned, we'll see that relationship gets more complicated. Okay. So we're going to start with some behaviorists, and the first one is Edward Thorndike. And I'm going to say right now for Thorndike, one is he's going to start the methods that we're going to use in behaviorism. You see this chart here, you see a creature right here that has to solve some problem and whatnot. But the importance of Thorndike, and I want to bring this to our attention now, is he wrote a influential book. It's a very short book. It's an easy read called Animal Behavior or Animal Intelligence, if you depending on how you translate it. Okay, and what his main argument is that what we observe in animals translates to what we see in human beings. And he used, I don't know why he used cats. If any of you are cat owners, you can imagine how interesting it would be to do these kinds of experiments. But he used cats. I think he probably used them because they're probably, very independent. They can either, like humans, they vary in their attachment ability. Some don't like people at all, some love people. I think he might have seen maybe some of the humanness in cats, but I'm not sure why he used cats. But what he did in his experiments is he would, kind of not feed the cat. And again, if you have a cat, you don't feed them, you know what happens. And what he would do is he would put a cat in what he called this cat box. Okay. And then he would set the kitty food just outside where the kitty couldn't reach it. Sorry for the bad shaped bowl. Okay. Yeah, but in order for the kitty to get to it, they have to open this door somehow. Okay, so in this case, the kitty looks like he needs to pull down on this string, and then the kitty can get out and have the kitty food. Okay. Well, if you can imagine, what he used was time, how much time it took for the kitty to solve the the puzzle. Now, I will say in some of them, they had to pull down a little string. In others, they had to push some button in other trials. And so the unique thing about Thorndike's cat box is on each of these, the mechanism the cat had to do in order to open the door could differ. Okay. And so what did he find? So he found that by measuring time in seconds, that regardless of the escape mechanism, whether it was pushing a button or pulling a thing, the cat learned very quickly that it had to come up with some fixed escape strategy. And it took them less and less time over successive trials in order to escape from the cat box. Okay. For Thorndike, this was evidence that learning increases our ability to problem solve. Okay. Now, for behaviorists, that's a stretch, right? Because it's a stimulus response kind of thing. So, a cat learning that if he pulls a string this time, that maybe pushing the button next time would solve the problem. That would be kind of counter to their idea. But what it did show is that learning can occur quicker over time. Okay. And so this gives us some methods. We can measure time to measure learning. And as we will see, we can measure the number of trials or the number of errors that someone makes in order to solve a problem. Okay. The next person, now Ebbinghaus, we're actually going to come back when we come to the memory section. The reason why I'm bringing Ebbinghaus up now is Ebbinghaus was the first to recognize that in order to actually prove that learning happened, you have to have a novel stimuli. Okay, which later on with Watson is the reason why he used an infant in his sometimes known notorious little Albert experiment, because little Albert didn't have experience with the stimuli of little white rats. Okay. And so, in order to make it so previous learning didn't interfere with current learning, they're going to kind of take what Ebbinghaus gave us when he did his forgetting curve, and and I can't think now, and show that that that's the best way to show someone has learned something. Now, in Ebbinghaus, again, we're going to use things like elapsed time and how much is retained. Okay, so I'll rehearse this to kind of give a point. What Ebbinghaus would do is he would come up with some nonsense word or syllables, okay? Something that someone could have never heard before, okay? And he would have them memorize it over, but through repetition, over and over and over and over. And then simply he would then just ask them after a certain amount of time, so time elapsed in days, how much they still remembered. So you get someone to learn a list of, usually you have them learn a list of syllables or nonsense words. And then you see how many of those words they recall. And you can see in 20 minutes, let's say we had a list of 10 nonsense words. They remember about 63% of them. And then after an hour, it goes to about 50%. And then one day we go, and then after about the fifth day, we remember less than about 10% of that original list. Okay. Now, the important part of this when we get to memory is that we will see that unless we continue to work with our information, okay, if we continue to integrate it and learn it and process it and remember it, we forget most of it. Okay. If you think about, one of your most boring classes, a subject you can't remember, I'm willing to bet that after you finish that class and within about a couple weeks, you probably only could have recalled about 10 to 15% of what you probably learned in that class, because it just was not that significant to you to make it so that you continued to work with the information you learned and continue having it as part of your everyday, if you want to say, or at least a couple of days of things that you recall. Okay. So, but for now, what I want you to remember is Ebbinghaus introduced the idea that for learning, we have to have some type of novel stimuli. That's why we're going to use buttons and we're going to use string pull in those kinds of things. Okay. And then the third person that was probably really influential in this first area that we're talking about is Ivan Pavlov. Okay. Now we're going to get to Pavlov, but what he introduced is the idea of associative learning, that we can learn without actually acting or operating with an object. Okay. And we'll see here in a minute, Pavlov. I just want to give a little bit of background on Ivan Pavlov, because I've always thought it's interesting that his what is it called, the big science award, Nobel Prize and everything was on classical conditioning and not what he was actually studying. If I were to think of Ivan Pavlov today, I would say that his work on understanding stomach acid and acid reflux, which led to the introduction of things like Rolaids and Tums, would be equivalent to what he did with classical conditioning, at least in my life, I know. Because what Ivan Pavlov was actually interested in is not learning or behavior, but our digestive system. Okay. And we'll get to this here in a minute, because there's some terminology and stuff that goes along with it. His famous, ring a bell and the dog salivates comes from this idea, is what he wanted to know actually in his original study is, does the intensity of food increase or decrease our hunger response? And he measured this through the amount of saliva a dog would produce depended upon the strength of the smell of the food powder that they were giving the dogs. But we're going to learn from Ivan Pavlov something called associative learning, that we can learn something without even knowing it. So I'm willing to bet that when you go to the kitchen, you kind of feel hungry. When you walk in the restroom, you kind of feel like you might need to use the restroom. Um, you drive by the Golden Arches, you might kind of feel like you want to, a McDonald's or something. Okay. That things that seem innocuous, if they weren't presented with something over and over and over, would have no meaning. Okay. And we will see again, now we'll go back to things like topics of addiction, topics of habit, topics of why do I always do this when I'm at this certain place or this certain time. We'll learn that it has a lot to do with the environmental cues that automatically kind of produce that need for that behavior. Okay. So we'll talk about associative learning a little bit more. But Pavlov again kind of gave that model about how we can research stimuluses in the environment and responses of the organism. Okay. And again, we will get to this guy more. I don't know if we're doing him right now, but John B. Watson, as we said in the beginning of the semester, he was kind of the father of behaviorism. And what he's going to show kind of in his beginning of the research is that things, emotions and stuff can be learned, such as fear, such as when we should be happy or sad. That while those are basic human emotions, how they come out how they are experienced often is through some type of associative learning. Okay. And we'll go through the little Albert experiment in a little bit more detail to kind of show kind of the rules and laws of how this can show. Now, you just noticed that I used a mental word. I used the word emotions. And you might be going, well, Dr. Peterson, you said that behaviorists were not interested in internal experiences. Okay. But I want to make it very clear. Remember, emotions are internal and external signals that something is right or wrong. So he would have not used emotions such as little Albert is experiencing this deep, dark feeling and internal need to escape. No, what he would say is little Albert was experiencing fear as noted by his crying and his crawling away from the stimulus object. Okay, so just want to make sure we're clear on that, because that kind of can mix individuals up. Is he was looking at those external cues of fear, not the internal ones. And then when we get to B.F. Skinner, he's probably, if Watson is the father, he is the poster child of learning theory. And what he's going to introduce is the idea of reward and punishment, or what happens when an organism acts upon a stimuli And he's going to argue that it's based on reward and punishment will determine whether or not you will see that action in the organism more or less in the future. Okay. And we'll talk about how reward and punishment really kind of work. Okay. But when we get to this section, we will bring up some human caveats to reward and punishment. For example, reward and punishment don't always necessarily work when you provide choice. And I'll explain how that works when we get to reinforcement and punishment in that section about if you're trying to train your child, for example, you shouldn't tell them what the reward and punishment is going to be, because then that implements the notion of choice, which for humans leads us to either make really good decisions or really bad decisions. But we'll kind of give that caveat when we get to really defining B.F. Skinner's contribution. Now, I will note there are some things about B.F. Skinner that need to be noted. Is he primarily did experiment with pigeons and rats, mainly pigeons, but he famously argued that if you bring me your child and using the rules of operant and classical conditioning, I will make your child into whoever you want them to be, whether it be a garbage man, an attorney, a judge, or a doctor. And yes, this is some of the controversial parts of psychology. Is he did build a child box that was modeled after his operant conditioning box that he used for pigeons. And yes, he did have the intentions of putting children in these operant conditioning boxes and raise them for a time being. Fortunately, they didn't go through the human rights committee at the university. So he said, well, if I can't use other people's children, I will use my own children. He had quite a few at the time. And at that point, that's when Health and Human Services got involved and decided that that wouldn't be a good idea either. So, so just so you know, no child was ever put in one of these. There were definitely intentions to do so, but that's how extreme a lot of behaviorists got, is that they felt if you can control the environment enough, provide the right reinforcement history and associative learning, that you can make someone into whoever you want them to be. So, and so we will talk a little bit about how that went awry. And probably this was one of the starts of the downfall of behaviorism, where we realized that there's probably much more to humans than stimulus response associations. Okay. And then if you remember at the beginning of the semester, we talked about, just as a reminder to kind of keep these names in mind, he was actually the first to design a precision bomb using pigeons and a map. So if you remember that from the beginning of the semester. So behaviorism had some extreme ideas, and B.F. Skinner, I will say, was the most extreme. In fact, on his deathbed, he was actually writing a manual in defense of behaviorism. And that was, I believe, 1992, if I remember right. It was either 82 or 92. He was still at this belief system that the answers to the human condition are through operant and classical conditioning. He even wrote a book, Walden 2, which is based on a utopian society that uses just reward and punishment to shape this little society called Walden. So kind of some interesting stuff. The last kind of person that we'll kind of talk about, or kind of person who kind of started some movements and ideas about learning and behavior, is Albert Bandura. And he's going to come up with a concept known as social learning. Okay. Now, he's going to note that humans are, again, one of the few species that engage in what is known as social learning. Okay. If you look at, for example, how a wolf learns to hunt, how uh, we'll stick with a wolf. I'm coming up with examples. The argument is that's mimicry. That's not actually learning from the mother. They're mimicking a behavior that then strengthens the neural connections that are already there in the brain so that the survival of the wolf is possible because they have to mimic that behavior in the environment that they live in. Okay. And so what was argued, or and is still really argued, is that humans have this unique ability to social learn, which a lot of people have argued, or a lot of psychologists have argued, is the reason why humans have been able to adapt to every environment on the earth, where other species adapt only to those environments in which they mimic to learn how to survive in that environment. Because what social learning allows us to do, and I'm going to give a very simple example, is let's say we're learning how to cook spaghetti. Okay. So, I sit there and I watch how my dad made it, how my mom made it, how my grandma made it, how my, um, um, I don't know, sister made it. So I have all of these examples of how people make it, and they may make it all similarly. Okay. Um, and, but what's unique is let's say dad uses oregano, and I don't know if don't follow this ingredient, and let's say grandma uses cilantro, I don't know, and let's say mom uses Roma tomatoes instead of table tomatoes. Okay, well, the as a human, you have the ability to say, I like the oregano and I like that flavor of that cilantro. And so they may combine those together. And, I noticed mom, she used Romano tomatoes. I'm going to mix the Romanos with table tomatoes and see how that comes out. So the unique thing about humans is they're able to observe a whole bunch of behaviors that are producing what's supposed to be the same thing, but then take parts from each of those individuals and make something their own, or make it unique to their own behavior. Okay. And this is something, again, this is going to break the rules of behaviorism. This is going to be the start of the idea that how we think and we construct our world internally is important. But this is going to be the last type of learning. And we will review what is known as the famous Bobo doll experiments, where a child either observes a teacher violently putting together a Bobo doll, or a teacher just puts it together regularly. And then we observe the behavior of the child the next day. And we're going to find, and this is where I'm going to pause here and leave the rest of the story for later, is whether the child was aggressive or not was dependent upon the behavior of the teacher the next day as well. The classical interpretation is that a child who viewed the teacher who was aggressive the next day. The child who viewed the non-aggressive teacher was non-aggressive the next day. But this is where we're going to have to clarify some of the popular interpretations of this experiment, because it's actually a lot more complicated than that. There's actually some other modeling that comes down to social learning that actually determined whether the child was going to be aggressive or non-aggressive. So we're going to leave that one for a cliffhanger. But Bandura is going to start introducing the idea of cognitive structures, that we use cognitive models to determine our behaviors or our actions. And this is going to be kind of the one of the ends of behaviorism is with Edward Tolman, which came up, which we'll talk about in more detail later on. I kind of want to end this historical part of the lecture. But what he's going to show is that we actually actively construct mental maps, and mental in order to navigate our world. And I'll give kind of a simple example. Tolman was a well-respected experimental psychologist. I believe that he did work at Stanford. I'll clarify that later, but at a very prestigious university. And if you could imagine, as a new student walking by his lab, one of the things that you may picture is Tolman or his research assistant pulling a little rat in a little tiny red wagon, and he'd be pulling him around these maze or this room and just pulling the little guy around over and over and over. And you might think, okay, so at this university we give rats rides in in um, in wagons, but that actually was not the intention. What he actually showed is that by just pulling the rat, without the rat actually have to walk the maze, without the rat having to look at each corner and everything else, by just pulling the little guy around in the little red wagon, the mouse actually could navigate the maze just as good as a rat who actually physically went around the maze, which indicates that what the rat in that what we do, and we'll show this, we actually build cognitive maps in our brain. And in fact, within your hippocampal area, you have what's called location neurons. So there is a neuron that actually lights when you think of the location of your house. There's a separate neuron that lights when you think about your workplace. There's a separate neuron that when you're in your house that lights when you think about your kitchen versus when you think about your bedroom. And what these neurons are coordinating is planning how you're going to get from point A to point B. Okay. And this is why we experience things like when we get in a car and we're either really, our minds running 1,000 miles per hour, or we're really tired. I can use an adult term, we're really hungover. And we go from our house to work and we can't remember how we got there. Mainly, the thing that guided us is that cognitive map in our brain that triggers those specific locations, that allows our brain to navigate from, for example, from our home to our work. Kind of a cool thing if you think about it. All right. So this is where we're going to head into tomorrow. We're going to get in a lot more detail about classical and operant conditioning. And then we'll finish off with social learning. Okay. And then we're going to talk about kind of 3 rules that can be applied across all these types of learning. One is generalization. Okay. Generalization is, for example, when you associate a kitchen with eating, and so you eat when you're in the kitchen, you can go into almost any kitchen, no matter how it's arranged or it's designed or how it is, and you will experience that. Discrimination is the ability to tell the difference between 2 similar stimuli, but because they produce such a different reaction, you don't necessarily, you can avoid one and approach another. And I think of a good example of that one. I'll have to think of an example of that one. And then spontaneous recovery is when we have unlearned something And then if there's a rest period from unlearning it and we interact with that something again, that behavior automatically returns. The best example I'm going to give for this right now is relapse with someone suffering from addiction. So let's say they've gone completely sober, they've learned all the coping skills, but then they don't continue to practice those. And then over time, all of a sudden, that substance is put in front of them, and then they could go through a relapse. They'll go through use again. Okay. So that's spontaneous recovery. Okay. And we will start with this video tomorrow because kind of running out of time for today.